Okay, I'm going to do this very fast because the previous speaker took all my time. And guess what the AV system guys do? He only left one bar on the mic.
Here you go, Dennis.
So it will go automatically shut down. So, who knows about big data? Who knows that big data actually happens in this room? Nobody? Okay, let me tell you. Anita, when she went on stage
You're doing very well.
earlier on, she asked a question. She said, who knows Sage? Wow, the result is just a handful of people showing their hand. She get very worried. Immediately she asked the next question. Who are the partners here? Wow. Again, she get a second wow. It's just a handful of people standing up. So immediately, all this data go into her processor. She was running 1,000 gigahertz. And that 1,000 gigahertz tell her that I'm going to keep on saying Sage throughout my presentation. And guess what? Have you all counted how many times she mentioned Sage during her presentation? Give a guess. I counted. 40? Anyone? Wild guess? 98? She actually mentioned 132 times the word Sage. Bravo. And that is big data, right? So let me just move. Skip this. So there is a study done saying that by 2020, we are close to 1.7 megabytes per second of data generated in the population, the world populations. Every individual is generating about 2 megabytes size of data on every second basis. And these data are huge. And just last year itself, people are spending about, worldwide spending on big data is close to about 57 billion US dollar. That is a massive spending that the world is doing. And quickly, let me just show you some context in Malaysia. This is a report done by Frost Sullivan, right? I think if you can read, the public sector, healthcare, and retail are the major players in Malaysia that believe in big data. They spend a lot in big data, and this actually shaped the economics of Malaysia, right? Why healthcare is important? Just give you a very simple analogy over here. Malaysia is well known for dengue. And we need all this data. And we need to know and inform DBKL or any municipal council to go to the area to do fogging, else they are not going to go there. When there's an outbreak, there are few people who get into dengue. They need to pull all this data. They know that, okay, those are the hotspots. I need to go and do fogging. Very simple analogy, why they use big data, right? I'm quite surprised to see these statistics that FSI are not investing enough in big data, right? I guess that's the reason why my bank always call me, do you want to do a balance transfer on credit cards? I'm already your credit card user. So there's not enough insight in customer profiling, right? So another chart from IDC. IDC helps us to understand what is this all about big data that we are talking about. It's not about what Stan says, you need to buy more hard disks because my data is getting big. It's not the case. So there are many types of data. There are human data, machine data, business data, system data, and you name it, it continues to grow. And this data will just be there. And what it means to you, right? It means nothing to you if you do not contextualize it. And this is what big data is all about. So you're going to move them into a system. That's where you do data acquisition. And then there will be a lot of analytics being done where the processing is, and the outcome will be business decisions. How are you going to make it? Right? Very simple. Step 1, step 2, step 3, step 4. First, data creation by machine, by human, by system, by application. Data acquisition, do the transformation, and the outcome will be business process. These are the typical use case that, depending on what kind of industry you are in, but these are the use case that you can actually build based on big data analytics. In the case of manufacturing, there will be a lot of work done in R&D. And how this R&D, the success and the failure throughout the R&D research means to improve the products that you are going to build later on. All this needs a lot of data points. The old days are where they're going to capture all this data and the scientists just run it against Excel spreadsheet. Well, the tool can be evil, but a lot of people use it. Those are unstructured data. Later on, when we evolve, we try to put it into a database, and they are more structured. But how do you want to put both unstructured and structured data together and try to mine information? And that's where the challenge is. And this is where what big data will do. So this is just one of the sample of use cases that normally manufacturing do a lot. And one point that I want to highlight is that there is also this thing called QA and QC. QA and QC is a very rigorous process that you can't put a security guard kind of a person sitting down there to just monitor the production lines. Production lines work like, very fast. If you are, depending on what kind of production lines. If you are looking into fast-moving consumer goods, like bottling, they go just very fast. But how do you detect that one single bottle or one particular bottle or one batch of production line that actually went into faulty? And you've got to detect it early before the end of the processing. That's where you have a lot of IoT devices to pick it up. And all these informations have to be furnished back into what we call a repository, where you analyze the data to prevent that from happening again. Or it can be real time to you so that it can alert you to stop the production lines immediately, so that there will be less more damages or losses it could be incurred, right? So the challenges today we face when we say that how are we going to start with big data is that, first of all, we are scared, we are very worried about the amount of data that we are seeing in your organization. It could be machine data, it could be any type of data, human data, system data, application data. But most importantly is there are data there. But what am I going to do with it? Okay? And there are a lot of technology innovation coming out. We are talking about IoT devices. There are many sensors in manufacturing plant, and all these sensors produce data. And what it means to you, because this data could be only understandable by machine. And how do you want to make good use of this data? Right? So this is one of the key challenges. And then you look into all this, how do you by planning it out? Again, just now, Stan did mention about, you have a strategy, you must have a plan to support it. And how do you come up with a plan? You need historical data. And you need enough data to support your plan so that you can execute your strategy, right? Same goes for predictive maintenance. How often are you going to do your maintenance before it fails? You don't wait until it fails, then you call your handyman in to fix some of the machines, and that's going to stop the entire production line. And that's what the case study earlier on showed. Missed opportunity, time to market, that will cost you billions. Last but not least, of course, the supply chain management. In manufacturing, supply chain is very, very important. It's key. And that's how you go into what we call the time to market. Oversupply, undersupply, material forecast, all these are very, very important. And big data really helps you overcome these challenges. And the challenges over here is to help you to drive this decision making. On top of that, there is a lot of monetization for the data that you have, right? So how does it monetize? First of all, with the set of data that you have, you can predict the output that you can control, and you know the sales pattern that you have, and you can correlate this information. You know that you can stock up earlier to meet the demand in the market in a timely manner. So that means that the data that you have on hand help you to monetize, right? And there are many, many other benefits that you can get on. In the interest of time, I just need to speed up a little bit. In the area of manufacturing industry, one of the things that I want to pick up over here is really product quality through telemetric data or IoT devices. In NEC, as you know, I work for a Japanese company. Technology, they are number one in the world. In your manufacturing plants, I visited Japan, some of the manufacturing plants, they just put surveillance camera in every checkpoint of the production line. It could be building a steel material in an assembly plant. And every single checkpoint, they will record the process. And they put it into a machine learning to study the behavioral, how this production lines actually works. Throughout the period of time, they accumulated enough data to even predict that there could be a potential defect in a particular checkpoint of the production line. And that is what big data is all about, right? So it helps in very big, giant manufacturing plants. And these are real things that have success story happening around the world. So when you want to just move on, this is to help you to internalize, to put up strong justification of how you want to move into this digital transformation, because digital transformation is all about data analytics. We talked about the third platform. Part of the third platform, there's big data analytics, and that's the most important part. The others are just supporting. The cloud platform is just a technology enabler. Mobility, technology enabler, right? What is more important is the data. And Stan did mention a lot of his presentation earlier on. He touched a lot about data. And this data is the most important thing. It's a lifeline of a lot of business, right? So we start on doing things like accommodate what are the data growth in your organization. You have to know, you have the holistic view of it. Then you build a multi-tenant infrastructure. A multi-tenant infrastructure that allows you to accumulate all this information. And of course, eventually you will form a single repository. And this is the common words that you hear in the industry called data lake or big data lake. It is no different from a data warehouse. A data warehouse is just to store structured data. But a data lake allows you to store structured, non-structured, or semi-structured data. So it has more information than just a simple data warehouse. Then you apply analytics. Then this analytics will have AI to it, where it does a lot of predictive analysis, deep learning, machine learning. And last but not least, of course, all this process will help you to strengthen your regulatory compliance. So allow me to just do a quick pitch of what NEC is offering in this space. We offer an appliance, a very simple appliance to help you to do or kickstart a big data project. So basically, we will do a process of ingestion of data, be it whether structured, semi-structured, or unstructured data. We're going to transform this data within the same box itself, the appliance, depending the size of the data in your organization. We're going to store them, integrate them, analyze them, and then we generate reports for visualization purpose so that you can make decisions. So the result could be in the form of, you can make it as a data warehousing, intelligence report, analytics reports, as well as for machine learning purposes. Okay? So some of the reference solution model that is using our solutions, in this case, just a simple appliance to build a big data lake, is to offloading or optimization of your EDW or your enterprise data warehouse. I believe some of the organization has a data warehouse somewhere in your IT department. And this data warehouse holds structured information. And you spend quite a hefty amount to acquire this system, and it will only go on a series of more upgrades in order to keep up with the processing powers to generate more data. The goal over here is to offload this EDW by having all the data to store in a big data lake so that it will just generate reports when it is needed, and it does not consume the processing power of your EDWs that needs real-time processing power to churn out information. So this is a good step for you to move into offloading your EDW, including you could also mine information from the unstructured data that you have in your organization. You can also move into social media today. Social medias are real-time informations. That all these real-time informations feed can be pulled into a big data lake for you to do analytics. One of the use cases over here is that I will put up, how many of you actually has a linking account? Show a hand. Not many. I think it's time for you to create a linking account. The reason being is that if you have a linking account and you have a Sage HR system, potentially there are people who are putting integrations together. The disruption in the economy today is to kill off all the headhunters. There will be a lot of profilings of your linking informations against the job scope or JD in the HR system to profile candidates in the market. And they do analytics on it. And they will identify candidates and you will get calls from a company. So please update your linking account and you may just get a call from some companies, right? So this is some of the solutions model that we are seeing, some use case that you can actually build while just starting just a big data lake, a simple big data lake. In NEC, on top of the solutions or the products that we have for big data, we also have AI technology. The AI technology over here, as you can see it near our booth, one of our AI over here is to look at biometrics. And this AI technologies has been there around more than 30 years, right? So IDC has reported that one of the digital transformations that people are looking into surrounding the areas of security for the IoT purpose, as well as people tracking. And how do you track people? You need to recognize them by face or biometrics. And it applies a lot of all this AI technology into it. How do you think the law enforcement officer would be able to combat crime without all this artificial intelligence and enough data points? Right? So this is what NEC is doing. And we will also help customers to chart a roadmap in embarking the journey of big data. You can actually easily start off with offloading of your EDW if you do have an EDW. If you are using Excel all the times, we can help you to churn out more or better reports by correlating more information directly from the source instead of you exporting data out from individual system and you try to correlate it within pivot tables in Excel. So there will be more data transformations happening in big data lakes to generate those reports. Then the next step is really to move you into the traditional new data source that you have. The traditional and new data source that you have could be from the IoT devices, could be a new system that you have already invested. We're going to pull all this data together and contextualize it, right? Then next step is that data aggregation and classifications based on the use cases that you have. We do a what-if scenario. That's where AI is. And last but not least, of course, you do a cross-company data lake, which will help you to meet the highest level of what we call regulatory compliance. We have specific use cases for manufacturing. You will be seeing some of my team members out there. You can approach them on this initiative for big data in manufacturing. But I just want to highlight a few points over here in the interest of time. Pay attention to the bottom part of the boxes. In every single process, be it whether it's the digital manufacturing or operation efficiency, or last, the process optimization. The use cases can be easily developed based on the set of data that you have in your organization. We will have consultants to conduct a workshop and assessment to do this data exploration in terms of what kind of data sets that you have in your organization and how do we pull them together and realize the value of this data in order to develop this kind of use case. And these use cases do not just stop within these slides. It will continue to evolve. And that's the reason why they create new opportunity in this market called data scientists. Because data scientists, they are not just a technical person. They are a business guy who understands the business requirements and try to map it against the data or the information that you have within your organization. I'm going to speed up on this. So one of the things that we can actually do, this is one of the use cases that typically we will combine multiple data stream, and that's the business challenge. And in this case, the multiple data stream we can combine together, we form a data lake. And these data lakes, I mentioned enough, will help you to do a lot of simple reporting first before we apply more analytics into it. This is one of the multiple source archive and visualization use cases that you can actually look into. Cost optimization by offloading, or even though you retire your EDW and move into a full-fledged big data lake in order to do whatever analytics or reportings, which traditionally I think you spend quite a fair bit of money into investing in a large database and in a data warehousing solution. Last but not least, we can also do supply chain planning by predicting and trying to understand the demand from sales, productions, material forecasts, as well as the output of your productions on a specific period and time. Okay, all this requires data and analytics. So my second last slide, why NECs? A lot of people talk about big data. Why NECs? So we try to establish a differentiation between ourselves and some of the competitors in the market. First of all, we are not just a product pusher. We start off the engagement of big data journeys with all our customers by providing consultancies. We do not believe that the digital transformation will be successful without a big data plan. The big data plans have to start from within the organization to create what we call a data-driven culture. A data-driven culture is that everybody is making use of data to make a decision. It could be a real-time decision, it could be an instantaneous decision, or a decision that you want to make based on historical record, right? So that consultancies and workshop is very important. Then we move on to a pre-sales to piece together all these informations and try to create a design and architecture. Technical research and POC will be done. You will not be jumping into the bandwagon to put in the dollars on the tables and says that you need to invest into a system immediately, despite the fact that we have done a workshop and the architecture design has been done. A POC speaks 1,000 words because the outcome of the results tells you these are the information is needed based on the use cases that you want to develop. Then we will design and develop the entire system altogether, put in the integration, implementation of the system, and we will continue to support our customer. And that's the methodologies that NECs embark on in engaging with our customer for big data journey. So our key differentiator over here is that we have a one-stop solution. We are a SI for most of the big data projects in the markets. The typical big data projects that we are in are not just having the data from your system itself. We are also pulling data from other sources, especially in the social media. Today, social media has vast information. Just think about how Google does big data. Google knows where you park your car. Google knows when you leave your house. Google knows which coffee shop you actually visited. Right? Scary. And that's the amount of information that you can actually create to profile your customer if you want to. So, last but not least, I would say that we have data scientists throughout the world, and we are ready to deploy our data scientists to work together with you. So if you have any interest about these big data topics, do approach some of my colleagues who's manning the booth there. Talk to them, and I'll be around to talk to you all as well. So any question for me before I end the session? Nope. Okay. Thank you.
Thanks, Dennis. Thank you. Thanks, Dennis.